electrification, and we have energy efficiency, so to reduce consumption through optimizing or upgrading. So basically now this triangle means that these decarbonizations will be achieved through sustainability, energy efficiency, and digitalization. And here I will show how digitalization can help in our energy efficiency, how it can help our systems to be more efficient. Our how to say way of how we are doing it. Our goal is not to replace everything. So it means all the equipment is not efficient. Let's replace it immediately. Our goal is how we can get as much as we can from existing equipment. What is very important, because there is a huge cost again for removing of existing equipment, huge cost of production of new equipment, installation of new equipment, and again carbon emission from this process. So now with the digitalizations, with better controls, I will show how we can make our system more efficient, and if it is required, how it can be upgraded through some, I will show later, to some additional maybe systems inside, how we can bring existing equipment up to the level of efficiency of current equipment that we can find these days. So now digitalization and sustainability. So one of the leads are intelligent demand response. This intelligent demand response is, in one word, it is like we need to just give enough, for example, for cooling. Now here we have cooling demand. So this and heat gains are coming from outdoor factors, from external heat gains and from internal heat gains. So we are dissipating the heat, equipment here is dissipating the heat. So goal is not to reduce demand. So demand is the same, but how the most efficient way we can deliver this cooling to this space, to respond to demand. And what is very important, demand is not fixed. So how sun goes, that's demand for cooling will change as well. Occupancy of people will have a huge impact on demand, as well as huge demand on ventilation. So for example, here we need oxygen to breathe, and there are acceptable CO2 levels. So huge energy goes to fresh air handling units that are taking care about ventilation. So in some cases, if you look at the typical building and in total cooling requirements, just for cooling, just for air conditioning, 50%, in case that if you don't have any heat recovery system, 50% of cooling will go to for air conditioning. Additional 50% goes to fresh air treatment, to bring fresh air to the space based on the minimum requirements as per standards. Before, again, during design, we are actually designing everything as per peak occupancy. Peak occupancy is per worst condition, but this peak occupancy and the worst condition might never happen. So it means during the hottest period of day, everybody will be, so occupancy will be full and all equipment will work on full capacity. This will never happen. So I will as well show this oversizing issue and how it is connected to energy efficiency and increase of energy consumption, and at the same time carbon emission, and as well like purchasing and buying oversized equipment as well is correlated with higher emission input for production of that equipment. So we have grid integration of variable renewables, smart EV charging, detection of emission leaks, and what I will focus is digitalization for energy efficiency, so data collection and analysis. So now, if I'm a mechanical engineer, so maybe I will not explain it well, or maybe somebody can explain. What is the difference between digitization and digitalization? Does anybody know? So I will try to explain in my way as well. I'm a mechanical engineer, so please stop me if I say something that is not correct. But for example, we have analog controls, right? We have analog signals, right? So now we are in the digitization. So what is digitization? So we are moving those signals into digital language. This is a language that computers and our controllers, they understand, and they can analyze it, and they can process this information. So first step is data collection and analysis. So our building generates a lot of data. There are many sensors here, but those sensors are used for automation. So now to explain automation, so my impression about automation. So automation was there just to remove human factor from controls, and we have a fixed set point for on thermostat, for example, for the temperature that is required in this space. So automation means that our system will work just to meet this set point, and this is automation. But if you want to move step forward, so it means that we can collect data about temperature, about outdoor air, about humidity, about occupancy, and it is too complicated to analyze this data and to control to analog ways. So we will move first to digital, and then through digitalization we will process this data and analyze, because at the end it is not required actually to have a fixed set points. Those set points can change based on demand, and I will show later on how our systems are basically do this real-time optimization. So it is not a set point that was set once and it is there from the beginning. This real-time optimization depends on many factors, as I said, and one of the very important factor is outdoor air condition and CO2 levels. And as well, it can provide us benchmarking and actionable intelligence. So now, if you look at the energy performance and services, so there is on-site energy supply that is energy generation, can come through solar panels, so green energy. As well, we need energy storage, so we can use generation where we don't have during night, energy management, advisory services. But on the demand side, here we have this energy efficiency topic that starts with energy audit and monitoring. So we are collecting the data, we are analyzing the data, and we are coming through the different models. We are coming to the best decision of how to run this, how to run building system or industrial systems. And we are offering turnkey solutions. So basically, our solution solutions that we are developing. So purpose of this solution is to provide energy savings, and as well we need to measure, we need to verify those energy savings, and we need to calculate. So what are the benefits of this solution, and how much we reduced carbon emission with our solutions. And as well, there are systems for asset performance and management, because now those solutions that I will present will provide a reduction in energy consumption, but as well as there are, and those are this energy consumption is something that we are quantifying, but there are additional benefits, because those solutions will reduce run hours of equipment. So it equipment will